Hello class, today we'll look at a new logarithm called the natural logarithm. And when you hear the word natural, I hope that you are able to link it up with what we did with exponential functions. We looked at one special base, which we call the natural exponent, which was base e, and we discovered that the graph of e raised to the x looked very similar to the graph of a to the x if a was greater than 1, right? So this was 0, comma 1, and then out of 1, you had 1, comma e. So let's see what happens over here when we try to find its inverse. Okay, so this is f equal to e to the x. Well, it's 1 to 1. It passes the horizontal line test, so we know that it's going to have an inverse. One way to find the inverse is to reflect it about the line y equal to x. So if we reflect, we're saying that the point interchange. So xy become yx. So the point interchange. So I got 1, comma what? 1, comma 0. And then we have e, comma 1. So put e over here, put 1 over there. So now we have a new graph that looks like that. All right. So that means that it has a vertical asymptote right here. So let's look at the phi. So this is what we are calling the inverse function. But we need to come up with the formula for that. So that's what we don't know yet. So if we go back to how we found inverses, we have f of x is equal to e to the x. We rewrite it as y is equal to e to the x, and we interchange x is equal to what? E to the y. Now, to solve for y, we now know how to do this. We need to move things from an exponential point of view to a logarithmic expression. So to change this, recall that this is exponential, so this is the base, that is the exponent, and then this is what we're going to call the argument. So if you move things around, you got log base e to the argument x is equal to y, which we should call f inverse. So now we know what this question mark is. That is what? Log e of x. So log e of x, we are going to kind of find a cool way to represent what log e is. We're going to write log e as ln, what we call the natural log. And then the argument just tags along. So log e is equivalent to what we are saying ln. And if you notice, it has no base. So just as we did with common logarithm, which had a base of 10 that we don't write, that's what we're going to do the same thing over here. Here, the base is what? E, but we don't write it. It's invisible. So when you see a natural log, it always comes without its base, but we know that the base is what? Base e. So we now really know what that inverse is. That inverse is ln x. So the graph of ln x looks like this. It's got 1, comma 0, and at e you add 1. So the graph is always going to look like that. Very similar to what the logarithmic function look like. And it's got a horizontal asymptote at x equal to 0. So some key features are the domain is what, x greater than 0. The range is all reals. And then it's got a vertical asymptote at x equal to what? X equal to 0. Okay. Alrighty. In our next video, we'll look at some transformations and then also look at domains of natural logs.